Number 7 is a classic problem where I give you 3 graphs and I ask you to figure out which one is the derivative of which. Okay? And there's probably many different strategies for how to do this. My recommendation is to pick one graph and then see if you can find its derivative. Okay? There's no real hard and fast way of doing this, but because I tell you that you're supposed to use each label only once, you can use a little bit of elimination in this procedure as well. So I'd like to start with the red function just for fun, and let's see whether the red function's derivative shows up here. Okay. So for our red function, notice that the red function is always increasing. Do you see that? So if the red function is always increasing, what do we know about its derivative?
It's always positive.
Good. If red is always increasing, then red's derivative is always positive. So when we're looking for red's derivative, we're looking for a function that always has positive y values. Do we have a candidate so far? I think so. I think purple might be a candidate. Okay. But let's talk a little bit more about that. If I went ahead and sketched some tangent lines on here, notice, like we said, the tangent lines always have a positive slope. But where are the tangent lines the steepest? The tangent line is the steepest right here, which is precisely where the purple one is the highest, right? Where red's derivative is highest, red has the steepest tangent line. Now, look also and see that on either side, the tangent lines, as we said, are still positive, but they're getting closer and closer to 0, right? They're positive slopes. It wasn't the best tangent line. They're positive slopes, but they're close to 0. Okay, so here I would say m is greater than 0, but close to 0. And that's exactly what we see right here, right? The purple function out there is still positive, but it's getting closer and closer to 0. That's because the original curve, red, is getting closer and closer to horizontal. Okay. So I believe that purple is red's derivative. Okay. So at this point, because I've only got 3 functions that I can use here, this is either my function and this is f prime, or this is the first derivative and this is the second derivative. Does that make sense? It's a process of elimination. So because both of them show, each one's only used once, we've got a function and its derivative showing up here. So it's either f and f prime or f prime and f double prime. Now, I kind of picked this so I'd go in the longer order just so we'd run through the whole problem. Let's go ahead and look at purple now, and let's see whether purple's derivative shows up. Notice that purple starts out increasing and then has a horizontal tangent line at 0 and then starts decreasing. So where purple is decreasing, its derivative would have to have what sign, folks?
Negative.
Yeah, where purple is decreasing, we would expect its derivative to have a negative, output negative values. I don't see any function that matches that, right? Having a hard time reading you, folks. Does that make sense? Okay. So I think that means that we're actually in this scenario here where purple is f double prime, red is f prime, and so by a process of elimination, that would make blue f. But now that we've done that, let's just check that. If I think that blue is the original function, then that would make red the original function's derivative. Let's see if that makes sense. Well, where blue is decreasing, red is negative. Where blue is increasing, red is positive. And where blue has a horizontal tangent line, where does blue have a horizontal tangent line? Right here. That's precisely where red crosses the x-axis, or touches it anyway. So all of that leads me to believe that we found the correct sequence of functions.